All right, let me make sure I get this straight because the last video I messed up a little bit. So the highlands, the lighter parts. Okay, so the lighter parts of the face of the moon are made of this anthracite, right? Which is it's a mineral that is made of calcium. It has mixtures of calcium, aluminum, and silicates. And it's as it says here, the highlands have a lot of craters as well. But the Maria, which is the much smoother looking in appearance. In fact, that's what they thought, that these were oceans. That's made of what's called basalt, and it's a very common thing that you find in near volcanoes. It's basically when lava has cooled off, right? So and turned into a solid. So the ones that we find on the moon are made of like iron rich basalt, magnesium, and also titanium. Right. So and of course because this basalt with these metals in them is going to be much denser than the anthracite. All right, so just wanted to make sure I straightened that out. All right, so here, of course, here are some craters that we find on the moon. It turns out that we don't think that a lot of them are volcanic. These craters are impacts. These are all impact. Almost all of them are impact craters. And in fact, any volcanic activity on the moon died down long ago. In fact, very shortly after the formation of the moon. And we're going to get into the formation of the moon, the collision that caused the formation of the moon shortly. All right, so they range in size. This is let's do this. So sometimes we see these the rims that are raised up a little bit. It depends on how the impactor hit the moon. Sometimes they hit direct, coming straight down. Sometimes they hit at a glancing angle, and it just changes the shape of the craters. All right. Let's see. They range in size from there's some that are smaller than centimeters. There's some that are as large as greater than 200 kilometers. In fact, one of the problems that we're going to do, just to let you know, I'll do this one a little bit later, is humans actually without the aid of telescopes or binoculars cannot actually see the craters. I mean, we know they're there because we've seen lots and lots of pictures like these, but you can't actually see a crater, even the largest ones, which are a little bit greater than 200 kilometers in diameter. You still can't see them because it's because of how far away the moon is, and what the angular size of these things. Some of them appear to be to have occurred much more recent in history, and some of them seem to be much older. The ones that are softer, like there's in other words, the material, there's no weathering on the moon, right? So this is just when there's been enough time for tiny little micrometeorites to hit the moon, then the older craters will look softer, right? As opposed to the ones that look like they're relatively new. All right, there are these micrometeorites, that little tiny, like almost dust-sized particles that hit the moon, And in fact, that's what causes the surface of the moon to be composed of this material we call regolith. Regolith is very similar to like if you've ever had baby powder, the baby powder in your hand, or some people call it talcum powder. That's pretty much the consistency of the surface of the moon. All right, and that's because of all these micrometeorites that have hit it. So these are so they call these riles. These are areas that have been caused either by lava flow, and so any stuff that was caused by lava flow was formed long ago. The riles are just these lines that we find on the surface of the moon. All right, so here's another one over here. Okay, so we don't see a lot of these happening now. These tend to be very old features on the moon that have been there almost since since the moon has been around. So the moon's formed shortly after the Earth's formation. Just to let you know. All right, the origins of surface features on the moon. As it says here, nearly all of the surface features, the craters, maria, and the rays. So these riles are sometimes called rays. The line, they're just lines that when if you're above the moon, like in a spacecraft, and you're taking pictures, that's what you call these things. These rays or riles. Anyhow, so all of these are caused, for the most part, by impacts, things hitting the moon. All right. And there's actually people who study this on Earth. They fire little BBs at at extremely high velocities at some sand, and then they look at what the formation of the different craters, what velocity that the BBs have to be traveling, and what else? Like when something collides with the surface of the moon, at what angle will some of the material spill over into another crater? All right, so it's people who study that kind of thing. All right, so what else? Let's see. So this is one of the Maria. So like for example, the one, this is not the one that the Apollo. So the Apollo 11 astronauts landed in how do you say it? It's Maris Tranquillus. I'm not saying that very well. So like this one is Mare Oriental, or sorry, Orientali. It's so they have different names, right? That's here. Let's go back to this picture over here. Oh no, they didn't show you the names of them here. So that particular one is this rather smooth region, and notice you can see the mountains around it. Let's see what else do we know about it. Mountain chains. All right. Anyhow, that's just one of the Maria. That's how you say it in plural. Maria. All right. Anyhow, the one that the Apollo 11 landed it's also known as the Sea of Tranquility. I always forget how to say it in Latin. It's like Maris tranquillus or something like that. All right. Anyhow, so this is the theory that it took a while for us to come up with. Why is it that there are regions of the moon that are very bright? Namely the highlands, and regions that are very dark. Of course, now since we've sent the astronauts to collect, moon rocks and bring them back for analysis, we know this much better. But until that time, which was more than 50 years ago, when people just speculated about what what formed the Maria, why are they dark, and so forth. All right, so here's how it goes. Okay, so the Maria formed when early in the moon's history, when you had really large objects. Okay, so these are certainly much bigger than micrometeorites. So let's say you have something with a diameter over 100 kilometers. I mean that would cause incredible damage, like unbelievable damage to the Earth. Right, if you had something this size hit the Earth. Anyhow, when these things struck the moon, they break through the crust. And so since we're talking about the very early stages of the moon still had, it was still hot enough to have, magma underneath the crust. And so the magma rose and basically filled in, where these impactors broke through the crust. And so that when they filled in, that's exactly what happens on the Earth. When lava cools, it becomes what we know as basalt, and so the magma fills in these craters, and they get kind of a darker and smoother look to them. All right, so. So this was a spacecraft that it might actually still be in orbit around the moon. It's called Lunar Prospector, depending on when you're watching this. Anyhow, the Lunar Prospector found evidence that there's lava that continued to flow in the basins over billions of years after the impact, due to like radioactive heating. Remember that's the same process that goes on in our Earth. Remember, the moon though is much smaller, so it doesn't retain its heat as well as the Earth does. But there was times when in the moon's history where there were volcanic explosion, or volcanic activity. And remember, you're talking about very early in the moon's history. It's been around for about 4 billion years. So it had time to do this. All right. So the structure. So the moon lacks what they call folded mountains, and the kind of mountains that we see on Earth. Okay, that was one of the first observations, is that it does have mountains, but they're really more like foothills. We don't have a lot of activity. Geological activity on the moon. The moon cooled off much faster just because of its size. It has a higher surface to volume ratio. Remember, we talked about that with the Earth. The Earth has a very large volume compared to its surface area, and so it retains the heat much better. All right, so since the moon is much smaller, it doesn't have as much radioactive material inside of it, and so it that source of heat, it has died down, it's just not as much. I mean, there's just not as much of it.